Dear students, welcome back to the video lecture of potentiometric method. In previous video lecture, we come to know the discussion on introduction and instrumentation of potentiometric method. Let us begin now. One of the experimental method for your theory as well as for the practical, that is estimation of ferrous ammonium sulfate by using the standard potassium dichromate solution by potentiometric method. The principle involved in the potentiometric titration is what? The measurement of EMF between the two electrodes. The two electrodes are used indicator electrode and the reference electrode. You know that indicator electrode is used for the measurement of the ionic species is to be measured from the solution, and the reference electrode is used as a support for the measurement, which maintains the constant potential during the course of the reaction. In this titration, the measurement of EMF is made while the titration is in progress. The equivalence point of the reaction is revealed by sudden change in the potential, that what you can confirm by plotting the graph EMF against volume of the titrant added during the course of the reaction. Now here EMF of the cell, how can measure? It is the cell EMF of cell is directly proportional to the oxidized form of the species to the reduced form of the given species. Here, as you know that E naught is nothing but the standard electrode potential of the cell, and here potential of the cell is controlled by the ratio of product to the reactants during the reaction. During the course of oxidation reaction, the product to the reactant concentration plays an important, but when the reaction is completed, oxidation reaction is completed, there is sudden change in the EMF at the vicinity of the end point of the reaction. So how this reaction we can explain? As you know that we are using ferrous ammonium sulfate in the form of ferrous sulfate, and it is titrated with the help of standard potassium dichromate in acidic medium. By using the sulfuric acid, you are able to get the products of ferric sulfate, potassium sulfate, chromic sulfate and water. During the course of oxidation, the ferrous ions are converted into ferric ions. When the oxidation reaction ends, then the reduction reaction starts. There is a conversion of chromate ion to the chromic sulfate. Let us discuss now about the experimental method, how to perform this experiment. You have to prepare 25 ml of ferrous ammonium sulfate solution into a clean beaker. Then you add 2 testful dilute sulfuric acid. Then in second step, immerse both platinum electrode and calcium electrode into the beaker and connect to the instrument is called the potentiometer, and measure the EMF of the solution for 0 ml addition of potassium dichromate. Then afterwards, add potassium dichromate from the burette in increment of 0.5 ml and measure the potential after each addition. The plot of graph delta E by delta V against volume of potassium dichromate and end point is determined by knowing the equivalence point. Then from the graph we can calculate the normality of potassium dichromate and also the amount of FAS present in the given sample solution by following this method. Here how to draw the tabular column. In the first column you have to write volume of K2Cr2O7 added, that is 0.0 for without adding K2Cr2O7. For every interval of time you need to add 0.5 ml potassium dichromate. In second column you are going to record the readings from the potentiometer, that is what EMF in terms of millivolts. If you know the EMF, you can calculate change in EMF, change in volume, and also change in EMF divided by change in volume. Then afterwards, you need to plot the graph delta E by delta V against volume of potassium dichromate is taken. You are getting equivalence point. That is what recorded as the VCC. And then from the graph, you can go for the calculation by knowing the normality of K2CR2O7 is 0.5 normal. Then volume of K2CR2O7, that is VCM cube from the graph. Suppose if you have taken ferrous ammonium sulfate as 25 ml, then calculate normality of FA solution by following this equation. Normality of potassium dichromate multiplied by equivalence point divided by volume of FAS taken. That answer what you get, that is what? X normality. Then amount of FAS in 1 dm cube of the solution, I am saying 1 liter solution calculated by this equation. X is the concentration of FAS multiplied by equivalent weight of FAS. As you know that X is from the first calculation by the use of normality equation, and 392 is the equivalent weight of the FAS. That whatever value you are getting, that is the amount of FAS present in the 1 dm cube of the solution. Let us discuss now some important applications of potentiometric titration. It is used for the analysis of pollutants in water, in drug analysis in pharmaceutical industry, in food industry for analysis for its quality of the food, to check the quality of cosmetics, and also used for the analytical tool in textile industry, paper industry, paint, explosive, etc. Now let us discuss about some important advantages of potentiometric titration. This is very economical method. It requires small quantity of chemicals for the titration. It gives more accurate results because of sharp equivalence point. There is no drawback of performing this one as compared to the conventional titrometric method. There is what we are using the indicator color change. There is no need to use the indicator for the potentiometric titration. This type of titration is a functional if the solutions are turbident, fluorescent and colored, and mass solution can be obtained very accurate results than the indicator method, and its automated endpoints you are able to get, and the results you are getting where they are more accurate as compared to the manual titration methods. Then let us discuss about few disadvantages of potentiometric titrations are. The main disadvantage is what? It is more sensitive. So if there are any impurities, so they will make the errors for the estimation. Then potentiometric titration takes longer time than the normal indicator method. It depends upon the nature of the reactants what we are using. Then it needs exact known concentration of the reactants of standard solutions, and it needs the calibration frequently, and it is very sensitive by change in its ionic strength. With this, the instrumental method for the analysis of potentiometric titration is completed. Let us discuss now conductometric method in our future video. Thank you one and all.